the museum Alrighty, everybody, I just got the okay to start the planetarium show. And we're going to be shifting gears real quick because now we're going to be heading into the unknown. Ooh. And once again, folks, welcome to the Morrison Planetarium. My name is Christian. I'm going to be your planetarium presenter for today. And just a heads up, I'm not a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm here. I'm going to be your planetarium pilot. And just to let you know, folks, the show that we're going to be doing here is different from all the other previous shows that we've done here in the planetarium today. This show is called Tour of the Universe, which is personally one of my favorites to do because essentially all we're going to be doing for the next 30 minutes is that we're going to be starting from Earth and then we're going to be zooming all the way out to the very edge of the known universe. Hopefully, by the end of the show, you won't have an existential crisis of where we are because we are very tiny and compared to the grand scheme of things. But we're also going to be seeing how much of humans' influence has traveled out into space and just figuring out where exactly we are in the universe. So, one of my personal favorite shows. And before we get started, I got to go over some quick house rules just so that we're all on the same page, can have a great experience in the planetarium. First off, there's no food or drinks allowed inside, so if you manage to bring any snacks or beverages, make sure those are tucked away till the very end of the show. We want to make sure that our planetarium stays clean for all of our future guests. This also includes no feces on the seats because, again, we want to make sure that our seat stays clean. And also, folks, if you happen to have any cell phones, smartwatches, laptops, anything that produces bright white light, now's the perfect time to turn them off, deactivate them, set them to stun, do whatever you need to make sure that these don't come out of your pockets for the next 30 minutes. These produce really bright white light that can be very distracting for the folks sitting behind you. So just make sure those are tucked away to the very end of the show. And also, the biggest of them all, please wear your mask while you're inside the planetarium dome. We've got about 40 people in this planetarium show right now, so we want to make sure that we wear our mask at all times, even during the dark portions of the show. We're going to be again in here for about 30 minutes, so thank you so much, folks. Can't stress that enough. Also, folks, if you need to leave the planetarium for any reason, the exits are going to be at the very top. So, when in doubt, always make your way up the stairs, not down them. This dome's going to get quite dark, and trying to walk down the stairs in the dark, that's a recipe for disaster. So, it's much easier for you to walk up the stairs as opposed to down. So, always go up the stairs, not down. And lastly, folks, this show can create a very immersive experience. If at any moment during the show you become overwhelmed, you become motion sensitive, there's a really easy solution for you to ground yourself. All you got to do is close your eyes, take a few big deep breaths. Your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling through space, at least not more than the usual. Hee hee hee. But otherwise, that's all I have to say. Y'all ready for a cool planetarium show? Yeah? All right, let's get started, y'all. Alrighty, like I mentioned, we're going to be starting off pretty close to planet Earth. Not exactly quite there, but you can see it just below our screen. In fact, it looks like we're hovering just above south of Japan, somewhere over the Pacific. And right now, we're starting off pretty close to this object here. Doesn't really look too familiar for probably for most folks, but what we're looking at is called the International Space Station. We also like to call it the ISS for short. But essentially, this is a spacecraft that we put into low orbit around planet Earth. And essentially, its whole purpose is to pretty much conduct science experiments. So, this is a orbiting research facility orbiting around planet Earth. And this is a collaboration between many nations across planet Earth. So, Russia was actually the first one to start it in 1998. And it actually has plans to continue to stay in operations till about 2024. But again, they conduct all sorts of science experiments up here. For example, they want to know how exactly does a plant grow out here in a low gravitational environment? Does fire behave the same way? How do you drink water in pretty much with no gravity? So all these things were pretty big questions that researchers wanted to find out when you travel out into space. And looking at the International Space Station, it looks enormous, especially here on our planetarium dome. But it's not too big, folks. It's only about the size of a football field. So not too big, but it keeps getting bigger every year because they keep adding new compartments, new modules to it. In fact, the one that we're looking at right now is comprised of 13 modules, and so they've been adding new ones to it every year or so. And what's really fascinating about the International Space Station is that this thing is orbiting quite fast around planet Earth. It's going a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, where it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And like I said, it's not too far away from planet Earth, but pretty up there. So the International Space Station is only about 250 miles above the surface of the Earth. 250 miles, that's not too far, at least in California. That's like a nice little road trip from San Francisco to Santa Barbara, a nice little getaway with the family for the weekend. And folks, this is as far as we put humans into space nowadays, at least 220 or 250 miles above the surface of the Earth, just because traveling out to space gets quite expensive quite quickly. First, you got to get yourself a rocket ship to get you off the planet, or build yourself a rocket ship. Then you got to get rocket fuel to get that rocket ship off the Earth. And you're going to need rocket fuel to get that rocket fuel off, and more rocket fuel. And essentially, you're going to need a whole heap of rocket fuel. And then you're going to need to bring all your electronics for life support. And also, you need to bring all the oxygen, all the food, and all the water you're going to be eating and drinking up here. So the bill starts to get quite costly quite rapidly. But we're going to leave the International Space Station alone. So we're going to slowly see it disappear compared to our planet Earth. And before it gets too far, I'm going to add a nice little trail so we can keep an eye on the International Space Station, because it's going to disappear compared to the Pacific Ocean. And just to let you know, folks, what's really cool is we are using a really cool space program right now, which is called OpenSpace, which pretty much you can, it's an open source program that you can download at home right now if you like. You would just go to openspaceproject.com. But just a warning, this program is still in its beta phase, which means is that it still has a few bugs and glitches here and there. If we encounter any while we're flying today through the universe, I'll let you know. And not only that, this program pulls real data from geo satellites that are orbiting around planet Earth. So if you're going to download this at home, make sure you have a really good computer that can process a bunch of information, like a gaming computer or sorts, because this takes up a good chunk of data on your computer. So just a heads up, but you can fly through the universe if you like once you get home. And that's openspaceproject.com. But we're going to be leaving Earth because now we're going to be heading over to our nearest natural neighbor to us in space, the moon. Now, we humans have been to the moon before, but that was quite a while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon, conduct science experiments, and they even got to play golf here as well. And it looks like we can only see about half of the moon right now. So I want to do some special effects here because we are inside of a planetarium. I can turn off the nighttime of the moon so we can get a better look at it. Hey, that looks pretty familiar. So now we're looking at the near side of the moon, folks. But again, we humans have been to the moon before, but that was a little more than 50 years ago. So quite a while. But don't worry, folks. We humans are planning to go back to the moon soon again, thanks to NASA's new space mission, which is called Artemis. And so it should be launching in the next year or two, hopefully, as everything goes according to plan. But essentially, what this whole new space mission is about, they're going to be sending the first woman to the moon and also the first person of color. And not only that, they're also going to be setting up a lunar base. Pretty much NASA's whole goal is to send humans to Mars. But before we send humans way out there to the deeper parts of our solar system, we need to figure out how exactly we're going to live on a celestial body. So pretty much setting up domes that are filled with oxygen. How are we going to be able to extract water? So these are all the different things that we need to figure out before we head out deeper into our solar system. So again, that is Artemis. Should be coming in the next year or two. Hopefully everything goes according to plan. Really excited to see what happens. And folks, here on Earth, when we look up at the moon, especially around when the moon's close to the horizon, it almost feels like you can reach out your arms and touch it because it feels so close. But actually, the moon's really far away from us. It's about 240,000 miles away from the Earth. Whew. Some of you folks in here may own a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for 4 months nonstop. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee. And from here on now, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities. So astronomers instead use a more convenient measurement known as light speed. Now, light travels at a mind-boggling speed of 187,000 miles per second. That's about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it takes light only 1.5 seconds to cross that distance at the speed of light. So let's say you had a friend on the moon and you had someone here on Earth. The person on Earth shined a laser to the person on the moon. They would see that laser in about 1.5 seconds. So that's really quick. But for now, folks, we're going to be leaving the moon behind. So before we leave, let's have everybody say bye-bye, moon. Bye-bye, moon. See you later. And now, folks, we're going to start to slowly see the moon and the Earth's orbits as they slowly recede. And now, because we're traveling so far out into space, it's going to be really hard to locate these objects. So now I'm going to be bringing up some planet trails so we can figure out where exactly everything is. And as we watch the Earth and the moon's orbit slowly recede, folks, on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate images and information available to us. And now the nearest star to us starts to come into view, the sun. And the sun is really far away from us. It's about 93 million miles away. Whew, 93 million miles away. In terms of light speed, that's only about 8.5 minutes at the speed of light. Now, that's a pretty cool concept to keep in mind because let's say if the sun was to turn off all of a sudden, the last bit of light that was emitted from the sun is going to travel that 93 million miles. So it's going to take 8.5 minutes to cross that distance and then finally reach us on Earth. And then all of a sudden, daytime would become nighttime. So it takes that long for light to travel that very vast distance. And we can also use the same concept for really far away objects. For example, let's say we're viewing a star that's 10 light years away from us. Well, we're looking at that star as it looked like 10 years ago in the past because it took that long for that light to reach us, which is pretty cool to say because the further you look at things out into space, it's almost like you're looking back in time. And since we're looking down on our solar system with a nice bird's eye perspective, let's name the planets real quick. So, of course, in the middle, we have the biggest thing. We have the sun, Sol. And then the closest planet to the sun, we've got Mercury. Then we have Venus. And, of course, we've got Earth. That's us. And then beyond Earth, we've got Mars. These are all the rocky terrestrial planets. These are places we can actually send humans to explore. But I wouldn't recommend it for a few of them. The temperatures at a few of them are quite hostile. But beyond Mars, we also have something really cool, which is known as the main asteroid belt. And this is what it would look like if we were to highlight all the asteroids in our asteroid belt. Now, this looks like a whole lot of asteroids out here, but it's actually pretty spread out. There's a whole lot of space out here for these asteroids to travel around. And this is a common misconception that tends to be shown in movies and cartoons and Hollywood pictures. Pretty much, you'll probably see somebody flying a spacecraft and they're dodging and weaving through an asteroid belt. Unfortunately for our asteroid belt, if you were to send a spacecraft from Earth and try to travel out through here, there's about a 1 in billion chance of your spacecraft getting hit by an asteroid just because there's so much space between all these asteroids in the asteroid belt. And then beyond the asteroid belt, folks, we have also got the big planets. We got the gas giants. We've got the Jovians. We have Jupiter and Saturn. And beyond them, we have the icy giants. We've got Uranus, the funny one, and Neptune. And of course, we can also add Pluto into the mix. So I just added Pluto's orbit. It's this light blue eccentric tilted orbit. And when we look at it from a sideways perspective, you're going to notice that Pluto's not on the same plane as the other objects that I just mentioned. And just to let you know, folks, Pluto is no longer considered a planet as of the year of 2006. And a lot of people don't seem to understand why Pluto got kicked out of the Planet Club. But it's because in 2006, we got really good about learning about our outer part of our solar system, specifically the region beyond the orbit of Neptune. So in 2006, we found more than 400 objects out here in a region called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? Well, here's the Kuiper Belt. Whoa. So again, we found more than 400 objects out here beyond the orbit of Neptune. And some of these things were way bigger than Pluto. So we couldn't call all this stuff planets. There was just way too many of them. So all the astronomers across planet Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And one of the criteria to be a planet is that you need to be so big and so massive that you push all the other stuff out of your orbital path. Unfortunately for Pluto, it hasn't cleared its orbital path, pushed everything out of its way, and it dances with its own moon. So this is one of the reasons why Pluto got kicked out of the Planet Club and is now considered a dwarf planet. But don't worry, folks, we've got a few dwarf planets out here in the Kuiper Belt region. We've got Make, and Haumea, just to name a couple. And of course, we have Ceres in the main asteroid belt, a little bit closer to us. But I won't put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be adding some of the spacecrafts that we sent out into our solar system to explore it in the 1970s. So here comes the trajectories of those spacecrafts that we sent out in the 1970s. Now, right here, we've got Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons. Now, all of these spacecrafts are traveling fast enough to escape the sun's gravity and leave our solar system behind. Now, what's really cool is that we can still see New Horizons, which is going to be right over here on the left-hand side of the screen. You can see it did a nice intersection or a flyby of Pluto in 2015. So in 2015, New Horizons did a quick flyby. We got some amazing high-definition images of Pluto because in the past, our photos were from Earth-based telescopes, and pretty much all the photos that we had back then were pixelated objects or pixelated photographs of Pluto, so we couldn't get a whole lot of information. But because of that 2015 flyby, we were able to look at Pluto in a brand new lens. And honestly, I could do a whole show about Pluto because it's just an amazing object in our solar system. But we're going to be leaving our planetary system behind, folks, now, because now we're going to be heading into interstellar space, the space between the stars. And as we leave into interstellar space, we're going to start to see the true brightness of our sun as it would look like if we were on the outside. And now our star system becomes one of many with all the other nearbys. Now, distance out here becomes so immense, it's going to take us about 4 years at the speed of light to reach the next star system to us. Whew, that is a very long road trip. And the next star system to us is going to be the Alpha Centauri system, which is right above our star system. Ours is right in the middle, so 4 years at the speed of light. But folks, we're going to start to consider if humanity has made its presence known out here in interstellar space, because now we're going to be heading inside the radiosphere. So again, we are inside the radiosphere right now, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All these things are emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. Now, humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. Since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, folks, the radiosphere is expanding at the rate of 1 light year per year, so is anybody out there listening? And right now, I'm going to be adding some markers onto the screen. These markers indicate some of the many thousands of stars astronomers have discovered over the last 22 years, which all of them have at least one or more planet orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found more than 4,000 exoplanets in our nearby vicinity, and that number is going to be constantly growing because we have a whole space-based telescope that's sole purpose is to find as many exoplanets as possible. So that 4,000 number is going to be increasing in the near future as it continues to scan our night sky. Now, to figure out if any of these exoplanets have conditions that are Earth-like, that are suitable for life as we know it? Well, we're not exactly quite there yet, but there are new astronomical instruments that are devoted to that search that are being built right now. But the important point here is that quite a few of these planetary systems within that 90 light year limit of our radiosphere could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. And of course, folks, planetary systems beyond the radiosphere, more than 90 light years away outside our radiosphere, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to put away those exoplanet markers, but I'm going to leave our radiosphere structure up there because this is a great reference point. As huge as our radiosphere is, it is nothing compared to the Milky Way galaxy. So keep your eye on it as we zoom on out. Can anybody see their house from here? Just kidding. And now, folks, we are looking down at our Milky Way galaxy. You can still see a glimpse of the radiosphere right there in the center of our screen. Now, our Milky Way galaxy is enormous. If you wanted to cross from one side of the Milky Way galaxy to the other, it's going to take you 130,000 years at the speed of light. Now, that is a very long road trip. And not only that, our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy alone. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way, I do want to stress the shape of it. When we look at our Milky Way galaxy from a sideways perspective, you notice that it's kind of like a flat pancake. Now, keep this in mind because this is going to come important later on the show. So, when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes and equipment galactically north and galactically south instead of looking through the plane of the Milky Way galaxy, which has planets, stars, nebula, black holes, gas, and debris, which obscures their view of the universe. So, just keep that in mind. It's much easier to look above and below the plane instead of through it. But folks, we're going to continue zooming on out. And now, the Milky Way is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, we're now seeing a view where each point of light represents not a star, but rather the location of an individual galaxy, each galaxy containing hundreds of billions, perhaps trillions of stars. And just to let you know, we live in a local group of galaxies, which contains about 30 galaxies, large and small. It also includes the large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door, and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And we zoom so far back now, folks, that we are looking at a picture that represents the 30,000 closest galaxies to us in space, over 300 million light years across. Now, we got to give thanks to a very special fellow by the name of Dr. Brent Tolley, who compiled this amazing galactic map that we're able to fly through right now in our planetarium dome. He was able to achieve this with the work of dozens of other astronomers working over decades of time. They even color coded the densest galaxy clusters in red or orange for us here in the planetarium dome. And by the way, folks, now that we've zoomed so far out, we can start to see structures in these galaxies. You're going to notice that galaxies are not evenly distributed throughout space. Instead, they like to clump together in large groups and clusters. For example, on the right-hand screen, you can see the Virgo cluster of hundreds of galaxies in a small knit region. And then there's also areas where there's very few galaxies or no galaxies at all, kind of like voids where they're kind of avoiding these areas. So just keep that in mind. Galaxies like to hang out in groups, and they like to sometimes just create voids, empty spaces out in space. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to see the large-scale structure of the universe. And remember, folks, every single point of light that you're seeing is not a star. It's an individual galaxy. Ooh, I feel small. And not only that, our universe is not shaped like a bow tie or a butterfly. Remember when I just mentioned that we live in a flat spiral disk of our Milky Way galaxy? Well, if we were to line up our Milky Way galaxy, it would line up just like this, vertically down the middle. So again, astronomers and scientists point their telescopes galactically north and galactically south instead of looking through the plane of that Milky Way galaxy. But scientists still wanted to make sure that there were still galaxies through the plane of our Milky Way. So we have this nice purple survey of galaxies right there. You notice that the galaxies don't go as far as the other surveys do, just because it's much harder to look through all that gas and debris of our Milky Way plane. But as our technology improves and our telescopes improves as well over the next few years or so, hopefully we'll be able to look through the plane of our Milky Way galaxy with ease, and we'll be able to map all these empty regions that have no galaxies there yet. So it's just a matter of time as our technology improves. But let's continue moving out, folks, because we still have a little ways to go, and it looks like we're running a little short on time. So now we're going to be zooming so far back that now we're going to be looking at objects known as the quasars. So these are very, very young, very distant galaxies. And the quasars are going to be all these orange dots that you're going to see at the very outer edge of the large scale structure of the galaxies. And not to mention, quasars are short for quasi-stellar radio sources, and these blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that we're looking at the quasars at a much earlier version of the universe. Pretty much, we're nearing the very beginning of galaxy formation with the quasars. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So now we're going to press on to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to approach the very edge of the known universe. And here we are. So we have now reached the edge. So this is what we like to call the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe we live in is about 13.8 billion years old. And this is from data compiled by Planck and other radio telescopes. And by the way, this is a very baby version of the universe. This is only 380,000 years after the Big Bang occurred, where space and time began. And what we're looking at is not a typical photo, but a temperature density image, where the light echoes of the Big Bang are color coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas are the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000. But eventually, they gave rise to that large scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how this happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years in time. Now, folks, we've traveled as far back as the law of physics can physically allow us, so we only have one direction left to go. So let's find a nice entry point through all these quasars and galaxies to make our return trip back to planet Earth. This looks like a good spot. And let's make our descent back. Alrighty, folks. We're crossing an expanse of 13 billion light years. Now, we present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy. New generations of telescopes and spacecrafts are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. With that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope. And not only that, there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But it looks like we're just approaching our Milky Way galaxy. We're heading straight for our radiosphere, folks. Now we're entering that radiosphere, and of course, we're making our way downtown, walking fast, faces past, and we're homebound. And now we're approaching our planetary system. about to pass those spacecrafts we sent out in the 1970s to explore our solar system, passing the Kuiper Belt. And of course, we're making our way to the third rock from the sun, our homeworld, planet Earth, the only place humans have ever called home so far. And folks, as we make our final approach to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me this afternoon. I hope you did enjoy it. And hopefully you got a little bit of a perspective of where we are in the universe. But hey, look at that. We made it back to planet Earth safe and sound. And that's all I have for you today, folks. Thanks for stopping by. Hope you had a good time.